Good morning.
Good morning, sir.
Yeah, I learned some left. I don't know that they are tired or
Okay, sir, let
you're
me
not.
call them.
Yeah, you're not system. So this is no. Okay, left that. Now, at the last meeting, we ended at simultaneous equation using elimination method. I hope you can remember. Can you hear me?
Yes, sir.
Guys, can you hear me?
Yes, please.
Okay. So we did elimination method. Is everything cool there?
Yes.
Okay. But are you been using the book? The model? Are you been using it?
Yeah, we've been using it.
So you're able to just solve it easily.
Yes.
Okay. Now the time is running very fast. And if you want to complete the module, you need more time. You want to complete the book. Now you are now the unit 2. I said if we can get let's meet to finish the unit 2 so that today we move on to different units. We could not meet. So if you are going by this way, then it means some of them we have to get, I have to touch them. But others are for you to complete it. Is it okay?
Okay, sir.
Math is unlike other reading courses, whereby they can get then we are done. This was how to take my time for you to understand some concepts. So it takes time. So now today I'm doing this linear equation with you. We are doing linear inequalities also even there. Then before we move on to unit 3, there we have the function. But since we are talking about the polynomials in the linear equations, left with the operation of what? Polynomials. How you can add two polynomials and so forth, how you can multiply and divide. That's what you can get you by going through the book. Are you okay? So that after this we can move on. If we get time, we can move on to calculus. So the unit that we are not able to do it is unto you to do it. If you have issue, then you can bring it out so that you all have it. That's how we are not doing the distance. So we are not get to do everything with you. The rest are there. By taking the most difficult areas to discuss it with you. That's why we are giving a very nice book. So if you are not be reading the book, please go and study the book. This morning I uploaded the assignment 1 on the LMS. Maybe you haven't gone there to check. Everybody should go there, do the work, and upload your work also on that platform. The date that you are submitting is there. It's not only that day, you can submit it. And when the day passes, the system will close. You won't be able to just submit your work there. So please let everybody go there. Maybe after the class to check the assignment there. You have to just send it there for you. Okay, so that after you have done your work, you just go there and upload the work for me to mark for you. Is that okay?
Yes, sir.
Okay, everybody should do it for your continuous assessment.
Okay.
When the time elapses, you can never get access to it. And nobody, I won't allow you to submit it. Again, I will open it for you. Lie. Okay. Now let's go straight to the substitution method. Now that you know elimination, now for elimination, we said that and both A1 and A2 are equal. Please, let's mute our microphone. If A1 is equal to A2, or let's say B1 is equal to B2, Andre, mute your microphone. And if you join with your full name.
Sir, please join.
Mute your microphone and join with your full name.
Yes, sir.
Okay. So if they are equal, then you check if they have the same sign. Let's say all of them are positive or all of them are negative. When it happens that way, we subtract one equation from other one. The variables that bear that equation or the variables whose coefficients are equal go away when you subtract because they have the same sign. And if they have different signs, what should we do there? We add. That variable will go away, leaving you only one variable in the equation for you to solve for it. And having done that, you go and put the value that you got for other variable into any one of the equation to solve for the one that you eliminated. They gave some examples. Today we are moving on to substitution method. That's why you take any one of the equations. Let's say I have equation 1, equation 2. One is saying that A1x plus B1y equals C1. Then if I want to do the substitution method, let me look at the coefficient of x and y in any one of the equations. It can be equation 1, it can be equation 2, any one of them. The one that seems to be very simple, we can make that variable the subject from that equation. So assuming I have x, the a1 here, it lets a 1. So here become my x plus by equal to c1. Now I can easily make x the subject. Okay, by sending all this to the right-hand side. So that I'll go ahead to substitute this into other equation. Now since I pick x from equation 1, after making it the subject, you can go to equation 1 and do your substitution there. You go to other equation. So I'll come to equation 2. Whatever I see as I put whatever I've gotten there, so that I'll be left with only y in the equation 2. That will enable me to solve for y. And having done that, I'll come back to maybe equation 3 or any one of the equations and substitute my y value there. In the same way, if I want to also eliminate y, or I want to make y the subject, that I do want to eliminate y, then I'll also make y the subject in equation 1 or equation 2, any one of them. You are not restricted to any one. So you can take equation 1, equation 2, make any variable at all, the one that seems to central, okay, the subject, and go and put it in the other equation. That is substitution method. For example, we are having two equations here. X plus 2y equal to 3 at 1, x minus 3y equal to 8 at 1. So we can name this one equation 1, and then we can name this other one also equation 2. So I think if you look at both equation 1 and equation 2, the coefficient of x are all 1, 1. So you can take any one of them. Are you following, please?
Yes, sir.
Yes, sir.
You can hear me?
Yes, sir.
All of you? Okay.
Yes. Yes, sir.
That's
We are following.
That's good, that's good, that's good. Okay. So going through the equation 1 and 2, we can take any one of them. So this one I took equation 1. And since x is having coefficient of 1, it's very simple. So I can just make it the subject easily by sending 2y to the right-hand side to join the 3. So by so doing so, I got s is equal to 3, this plus, so when it could become minus 2y, they are named that y equation 3. So you have equation 1, 2, 3. So since we took equation 1, we can't go back there. So you must substitute equation 3 in equation 2. So to me, when I go to equation 2, whenever I see x now is 3 minus 2y. So that's what you can see here. This is x, 3 minus 2y. Then I will continue minus 3y. X. All equal to 8. I think it's okay.
Yes, sir.
So here you could see that we don't have x again. We only have one variable, which is y, and you can solve for it. So we have 3 minus 2y minus 3y becomes 2 minus 2y plus minus 3y becomes minus 5y. So we get 3 minus 5y equal to 8. Therefore, by making y the subject, I can send 3 to this side. And when I do so, what am I going to get? I'll get minus 5y. Okay. Minus 5y will be equal to what? Will be equal to, yes,
Positive 5.
8 minus 3 which is 5.
That's the y.
Okay, I'll send this 3 here to this side. This one. So it becomes 8 minus 3, which is 5. Therefore, I'll divide here by minus 5. Okay. Here also by minus 5. So therefore, what is y?
Negative 1.
Y become negative 1. That's what we have here. So having gotten y equal to negative 1, then we can take any one of the equations. We have equation 1, equation 2, equation 3. Put y in any one of them. You get x. But since you have already made x the subject in equation 3, that one becomes easier. So you can go to equation 3 and put y equal to minus 1 in equation 3. X come. We get simplified. So that's why I'm having x equal to 3 minus 2. Now this is my y, which is minus y, equal to 5. Therefore, x becomes 5. Is it okay?
Yes, sir.
Good. Any question? If no question, let's move on. Let's see the second example. Now this one, equation 1, equation, you can see that equation 1, we have y with a coefficient of 1. So you can easily make that one a subject. Easily make that one a subject. So you can take equation 1 and make y the subject. So I say from equation 1, y is equal to 10 minus, I'm sending 2x to get 10 minus 2x. I will name it equation 3. Then we do substitution. We put 3 into 2. But when you go to 2 here, we have 4x minus 3. Now this one now is equation 3. With 10 minus 2x, that's what you can see here. Now equal to 12. So we get expand and simplify. We get x equal to 4.2. These equations, the first one, second one, we solve them using substitution method or the elimination method over the last week. And go the same answer. Go the same answer. So now that you are having x at equation 4.2, then we can go to equation 2 because we took equation 1 first. So go to equation 2 and put x value in equation. Not the equation 3 rather. When we go to equation 2, we come back to by making x the subject. By making y the subject again then. So let's go to equation 3, where the y is already the subject. And put the value of x there. Okay. So this. So we are having x equal to 4.2. So come and put it here. That part is missing, so you can do it. So let's put s is equal to, calculator, put s is equal to, so we have 10 minus 2 times 4.2. What are you going to get? What are you going to get? Yes, Are you there?
Which one?
Yes, sir.
We are here. We are here. We know s is equal to 4.2. So come and put it here and simplify for y. What is y? What is y?
16.
16. Are you sure?
It's 8.4.
Maybe you cannot see it well. So 10 point or 10 minus 2 times 4 point.
It's 1.6.
Point 2. Calculate that. What are you getting?
If you 8.4.
Do you have a
It will be 10 minus 8.4.
and so subtract it for me. Simple for me.
So it will be 1.6.
1.6. Yeah. That's for y. So y equal to 1.6. Okay. So that's for substitution method. So we have done elimination, we have done substitution. Any question? Any question? No. No question for me. Okay. Let's move on to the next one. Now I want us to even go ahead. This you can even use the graphical method. Now that you know how to plot a linear graph, okay? So the matter of just plotting the graph of equation 1 by using intercept method. When x is equal to 0, what is y? When y equal to 0, what is x? Are you okay? Then do the same thing for equation 2. So where the two lines are meeting, then trace to x and y. These become the values of x and y. Are you okay?
Yes, sir.
Yes, sir.
Okay. So that's why it's very simple. Now for this equation 3, I've done it for you, so we did not any problem. Let's move ahead so that we can cover a lot today. So get simplify this one and send all the variables to one side and then non-variable to other side. To get equation 1 like this, you have equation 2. So you can make either m or n the subject from each one of the equations. And then you go ahead. And I got m at negative 55 over 13. Then n is also at 50 over 13. Are you okay? So that's what I got by substitution method. Okay. Now the graphical method, that's what I was saying. So with the same equation that we did, equation 1, example 1 there for both elimination substitution, I can graph them as I was saying. So let's graph equation 1. So can you get the coordinates for equation 1? When x is 0. Okay, let's go for when x is 0, what is y? When x is 0, what will be y? You're here.
So y is equal to 3 over 2.
So for the sake of graph, change it to decimal. Over 2 is the same as what? 1.5. Are you here?
Yes, it's 1.5.
Yes, sir.
1.5. Only 1.5. Because the graph, if you live in the fraction, it becomes very difficult for you to know where you are going to trace it. So live in decimal. What about when y is 0? What is x?
X is equal to 3.
X is 11.
So it means that we have 0, 1.5, and we are 3, 0. Are you okay? So you get product. And they join the points with a straight line. Try to extend it. Then do the same thing here. Do the same thing here. When x is 0, what is y? When y is 0, what is x? And then you plot the two lines on the same graph. On the same graph. Okay. So that's what you have here. So we have x0, y 1.5, x3, y0. So that's what I plotted here. x0 here. Here's 1.5. Can you see it? Can you see it?
Yes, sir.
Yes, sir.
Good. So x0 here, y is 1.5. Now x is 3, y is 0 is also here. So we join them with a straight line. They are also plotted the second equation. So when x is 0, y is negative 2.7. And when y is 0, x is 8. So negative 2.7 is here. And here also become when x is 8, y is 0 also here. So I join them also with the straight line. And the two are meeting here. If I go to x-axis, x is 1. And y is minus 1. Or x is 5. And y is minus 1. Can you do that?
Yes, sir.
So this is because this one, I think it seems to be simple, eh?
I don't get it.
You don't get it?
Yes, sir.
Well, you hear when we were doing the last week, when I took you through the graph work. Did you join last week?
No, sir.
And then it's our own problem. Please. That's why there's no problem. Nobody should be blamed. Yeah, Jonathan.
Yes, sir. So with the graph, if in case you see the second equation, the y,
Yeah.
if in case maybe your graph, the way the graph is, there's no place to put a 2.7, minus 2.7, can you run it to maybe 3?
The more you approximate, you get there. Why can't you get minus 2.7? Now, every graph, like this one, pay attention, please. When we come here, this from here to here, this interval here contain 10 small boxes. I get my point.
Yes, sir.
10 small boxes that will form 2 centimeters. There will be square box there contain 10 by 10. Are you okay? So here 10 small boxes. I am saying that per my scale, 2 centimeters will be equal to what? 1 unit. So if I want to know small box there within that big square, I might divide 1 by 10. So I get 1/10 with the same as 0.1. So it means that every small box is 0.1. I get my point.
Yes, sir.
So if it's 0.1 and you are having negative 2.7, so you go to where the 2 is and they count 7, because everyone is 0.1. 7 will give you 0.7. I get my point.
Yes, sir.
Good. So don't run it on 1 decimal place.
Okay.
Don't run beyond 1 decimal place. Even 2 decimal can make it 1 decimal place, but don't go beyond that. The more you approximate, the more error you are getting.
Okay.
Now here, assuming you are running it, let's see what will happen. This one should become what? 3, negative 3. That's not true.
Yes, sir.
So that one will come here. You are changing the solution. And this one to 1.5, you got also 2. This one also will come here. And look at what we're going to get. So this line will pass here. And this also will pass. You see?
Yes.
You get the wrong answer.
Okay.
So the more you approximate, the more error you get. So don't try to approximate too much. Leave it at least 1 decimal place. The class, are you okay with that?
Yes, sir.
Now you see, let's see what we got when we use the other method. I think the same equation there. Let's check if the same equation that we use the graphical one for. Let's go to this equation. Not that one, eh? Yeah, this is the equation. Are you okay? That is the equation that we have grabbed them.
Is the same one?
The same one. And what do you get for y? Minus 1. Are you okay? What is x? 5. The same thing that we got using the graphical method. So we got x is 5, y minus 1. Are you okay with it? Ladies and gentlemen, are you okay?
Yes, sir.
At your school, they normally get, oh, we had a graphical method, but they don't teach it. Eh? They get mentioned it. And it's very simple. So let's see this one. We have the two equations. We are solving them simultaneously using graphical method. So this is equation 1. So by taking the intercept. So when x is equal to 0, I had 0.4. Okay, so put 0 here and then here make y the subject 2/5 with 0.4. And when y is also 0, and here becomes 6x equal to 2, that one becomes 1/3, which is also this. So you see that I have just approximated them to 1 decimal place. To avoid any A. Good. When you come here to when x is equal to 0, also let's plot this one. There's 0 negative. Now because the scale is 2 centimeters to 1 unit, one small box is 0.1. We divide the unit that we are using by the number of boxes that we have in a square. So if we are saying 1 to 2 to 1, then every small box is what? 1/10. And 1/10 is 0.1. Are you okay? Are you okay with that?
Yes, sir.
Now assuming if you're taking the scale as 2, here is 2 centimeters, 2 units. So here becomes 2, 4, 6, there. Then how can I get one small box? 2 centimeters to 2 units. So what would be the one smallest box? The measurement to do what? The same as 2/10 because every box contains 10. And that will give you 0.2. 0.2. It's okay. Please, are you okay with that one?
Yes, sir.
Good. So 0.2, one small box is 0.2. So when you add 0.25, what are you going to get? You get 1. When you add 10, you get 2. So that's what the measurement for the one small box. So take note of it. So I have my 0 to 0.4. So this is 0 and y is 0.4. So this is 0.4 here. Can do that mark there. Now, when we are 0.3 for x, y is 0, that one is also here. So I join the two, try to extend the line because you don't know where the other line will meet it. So try to extend the line. So we extend it nicely. Then when you go for this one to when x is 0, y is what 1.3, and when y is 0, x is 0.8. So this is what you have here. And that 1.3, 0.8. So we join them, we extend them so that the two will meet. And they're meeting here. Therefore, this is the meeting of the two lines. Hence, x now will be here, will be 2 here, and y will be here. Therefore, we have x equal to 2, y equal to -2. So So here we are just remove the risk of whether finding the what no, making this one the subject whatsoever. No, you put them where they meet, then you get your answers. That's all. Okay, let's go. If no question. Now with that, this is not part of your book, but I don't know. Let me take you through it. Let me take you through it. It will make it very nice, especially if you are having 3 equations or 4 equations and you are solving them simultaneously. Are you okay? If you have 2 equations, then it's not all that bad there. But if you are having 2, so let's see. We have what we call the Hammett rule in matrices. Those who did elective math, we have what we call a matrix. Matrix is of the form as this, where we call the rectangular array. So when you arrange objects or numbers in the rectangular way, we call it a matrix. So if I have A, it's going to have A, B, C, D. Now you see we have this and we have this. So those here, the horizontal, those on line horizontal, we call the row. And those vertical, we call the column. So we have row and column. So here we have 2 rows, one is this and one is this. And we have 2 columns, one this, one that. Therefore, this matrix is said to be 2 by 2 matrix, and it's a square matrix. Are you getting it? Are you getting it?
Yes, sir.
Good. So this is a 2 by 2 matrix, and it is a square because the row is 2, the column is 2, so the length and breadth are equal. We call it a square matrix. Now, if you are having, we can even have a matrix like this. Let's say A, B, E, let's say E, where all these are, it can be numbers, F, let's say G. I can have a matrix like this. I put them in brackets. And I will name it, let's say, P. Okay, can you see it? Class, can you see it? Let's hurry up.
Yes, sir.
Yes, sir.
Good. If you can see, let's so that we can go faster. This is not, this one you cannot find in your book. But I found it very, very nice. That's what I'm teaching you. So if you are lying, you are saying, oh, they have when I go to go, no, it is not there. And this will become helpful because we are having, let's say, 3 equations and you are solving them simultaneously. If you are going by elimination method, it will become very long or plenty. But with this approach, it's very simple. And you can use this one to solve even 4 equations, 5 equations simultaneously. Okay. So now this matrix is having how many rules? How many rules? Go to the horizontal one. So how many rules?
2.
2. One is this and this. How many columns?
3 columns.
So 1 here, 1 here, and 1 here. So this one is called 2 by 3 matrix, or matrix 2 by 3. We normally call the number of rows first before the number of columns. Are you okay? It's not 2 times 3. This time is by. Are you okay? So don't go and multiply them to get 6. No. It means that it has 2 rows and 3 columns. And this is not a square matrix because the length is not the same as the breadth. Are you okay with that?
Yes,
Are you
sir.
okay with that? Good. Now, if I have a matrix and I want to find the determinant, we have what we call the determinant. I can make all this number gets 1. Give the value to it, gets 1, the determinant. Now, if I want to find the determinant of a square matrix 2 by 2, let me rub it them so that it becomes clearer. If I want to find the determinant of this matrix A, you have it as this. You can use this symbol, again, like a magnitude sign. Here we call it determinant. Or I can make it det A. Now that A is saying that multiply A by D, that's across the diagonal. Are you again? Then multiply B also by C. And subtract BC from AC. So that of matrix A is A times D, this times that diagonal way, minus this times this. Can you see it?
Yes, sir.
Good. So I say that the difference between the product of the entries along the principal diagonal and the manual. If you say principal diagonal, means ADA, the principal, and the manual diagonal. Then you get your determinant. Okay, now let's try these matrices. So if I want to find the depth of A from the first matrix, I. Before you go to the solution, let's all try it here. So I can get that A now will be equal to what? 2 times 5. Are you okay?
Yeah, 4 times
Oh, 4 times 5 is what? 20.
20.
Minus 2 times 3.
Yes, that'll be 6.
6, which is equal to what?
14.
14. Good. So the depth of A is 14. Is it difficult? Is it difficult?
No, sir. No, sir.
Okay.
Let's go to the depth of B. What is also equal to what? 2 times 3 is what?
6.
6. Minus 5 times minus 4. 5 times minus 4.
Positive 20. Positive 20.
It becomes minus 20. Are you okay? That shall not be confused here. So we have minus by 10 to what? Positive. And it's okay now. That's why they say positive 20. I wanted to go step by step. So we can 6 plus what? 20, which is 26.
Yes, sir.
Are you okay?
Yes, sir. Yes, sir.
It is difficult.
No, sir.
Good. That's the determinant of 2 by 2 matrix. After that one, it's not difficult at all. So are you okay? We are not going to solve the what? Simultaneous equation. Are you okay with that?
Yes, sir.
So can I go straight to it?
Yes, sir.
Good. Do you have ladies here? Ladies, are you here? Any lady here? Yeah, they enjoy themselves. Wow, no lady is here.
They are around, Pastor.
Let me check the list. Maybe they are preparing some food there. They
Sir,
can
please, I'm
join.
here.
Hey, you do know that she was there, but she may be doing something different. Ellen,
Sir.
you are just connected and be doing something different.
No, sir, please.
Oh no,
Please, I'm
Ellen.
on
Oh, Ellen, wait there. Oh, wow. That's why when I call it lady, we could not respond.
Sir, please, I'm on it, but I'm lost a little bit, so.
That's why I'm asking. Because where are you having children?
So I'll find time and do it. I will do research
Where
about it.
Where you having problem? Tell me now. Where you having problem?
The matrix approach.
The matrix. We haven't even started that one. Are you okay? So you have issue. Why should you ask so that we can just move on? Eh? You found time. What time are you going to find? We are saying that if you have determinant 2 by 2 determinant, that's a matrix. 2 by 2 matrix. And I want to get the determinant. I just want to get a single number out of that. So I just multiply the number here. You know diagonal?
Yes, sir.
So this is the one of diagonal. We call it the principal diagonal. So I'll multiply the numbers along the principal diagonal. So this is A times D.
Yes, sir.
You get AD. Minus the minor diagonal. This was B times C. That's all. And then you simplify.
Yes, sir.
So here we have 4 times 5. The major diagonal is 4 and 5. So 4 times 5, 20. Minus 2 times 3, 6. Are you okay? So 20
Yes,
minus
sir.
6, 40. You okay then?
Yes, sir.
So this one is not a big deal. I should find times. What time are you going to find, Ellen? Here, 2 times 3 is what? That is 6.
6, sir.
Minus 5 times minus 4, which is minus 20. So you have 6 minus 20. It becomes 6 plus 20, which is 26. Are you okay?
Yes, sir.
So any area again, please.
Sir, please, I'm okay. Thank you, sir.
Ellen, Yanka, how? Are you only lady among us here?
No, please.
By that lady also here?
Sir, please, let me check.
You could not join. Some are not joining to go against them.
She's online. I think so.
Please, you are here.
You say she will also do something. What is it? No, the baby away. But let me connect and let them know that I'm here.
I came online.
Okay. Now let's go. So that's the solution for you. You see that you have here 14. We go here 26. Are you okay? Here is what? 10. And here is 0. So let's see how we can now solve this equation. And from here, we go straight to the simultaneous equation. So whenever I see this line here, instead of a bracket, now a bracket is something like this. Are you okay? Or maybe the normal bracket, this is a square bracket. But if you're using like a magnitude, you have to find a determinant. This sign is the determinant sign for matrices. So the equation, the matrix is saying that, or the question is saying that, if given the determinant or the matrix, negative 6, 2, 8x is equal to 20. Find x. Are you here? Negative
Yes, sir.
6 to 8x. You see, I'm calling them one by one because every number there stands for its own. Negative 6 to 8x is equal to 20. Find x. So we can just find the determinant here. So multiply negative 6 by x. We get next 6x minus 2 by 8. We get 16. That will be equal to 20. Are you okay? So come here. Very simple. Today we are going to linear equation. Are you seeing that?
Yes, sir.
Therefore, we can make x the subject from this equation and get x is equal to minus 6. So therefore, here it's also minus 6. I hope my people are following. Okay.
Yes, sir.
Now let's go to the climate through. It means we are not going to how we can use this matrix approach to solve simultaneous equation. But here we are going by only 2 by 2. Therefore, it means we are using only 2 equations. I don't want to bother you. You are diploma students. If you were to be other, then you should have gone through the 3 by 3 with you. Because the 3 by 3 determinant is different, a bit different from 2 by 2. Okay. Now, if I have an equation ax plus by equal to m, and this, and we have cx plus dy equal to n. We saw this one from the from the starting of simultaneous equation. I get the elimination of substitution. We saw this equation there. Now we are going to take the variables from each word equation. This one here becomes the left side. Are you okay? We are the left side of the equation. Is that not true?
Yes, sir.
And this is the right side. Eh? Are you okay?
Yes, sir.
So from this, I am going to form a matrix out of the left side by removing all the variables. Variables are x, y. Taking them out. Then the sign also. So it means here I have a here. So this is my a. This is the a. Next one is b. So this is the b. So I'm done with the first equation. Go to the down. So C here and D. Are you okay?
Yes, sir.
The rest of you, are you okay?
Yes.
We are forming a matrix from the coefficients of the equation to the left side. Okay. Now the x and y that you have taken, you also form a matrix of it. And that also becomes x. We have x is x, y. X, y. We have gotten our a, we have gotten our x. And the right hand side, mn, will also make b. So b also mn. So we are getting 3 matrices. One is formed by the coefficients of the equation, that is a. Other one is formed by the variables x and y to get x. And the b is formed by the right hand side, mn. So to me, the equation that you are getting here is the same as putting the equation in the form of ax equal to b. As equal to b. So if those who did the matrix, when you multiply x by a, you get the same 2 equations here. Are you okay? So this is how we want to do it. We want to express the matrix, the equation as a s equal to b, where a is the matrix A. That's the matrix that you form from the coefficients. and S will be the variables, X and Y. And B now will be the other side, the right-hand side values. So are you again? Please, are you okay?
Yes, sir.
Yes, sir.
Okay. So having gotten your A, B, and X, you are now going to solve for X and Y. X and Y. So what we are now going to do is we first find the determinant of A. Find the depth of A. Now you can now find the depth of A easily. What is depth of A? AD minus BC. Is that not true?
Yes, sir.
We get that one as my one. That's my depth of A. That you know X and Y, are you okay?
Yes, sir.
X and Y, the variables. That these are B. You know B, you can see the B there. So I want to form the depth of, so first of all, I'll get the matrix of AX. It's very simple, take your time. What am I doing this? The matrix of AX means that, you see, let's go here. What can you see here? When you go to the first column here, are you give the same as AX here? Are you okay?
Yes, sir.
So that column there is for X. And this one, the second column is for Y. Can you see that?
Yes, sir.
Good. You are doing well. So if you can see that, then it means that I am going to the matrix A. I want to get the determinant of X. So I'm going to the matrix A. I will replace the first column by B, Mn. Are you here?
Yes, sir.
That one I will give you my AX. And I found the depth of that. Get that AX. Then I'll do the same thing. I want to find the depth of Y. So Y is also the second column. So I'll also just replace the second column also by the Mn. Then I'll get my depth of what? AY. I hope you are getting me right.
Yes, sir.
So having got to a depth of AX and that of AY, you are done with the simultaneous equation by the climate rule. The rule saying that X is equal to determinant of AX over depth of A. That you get your X straightforward. So no matter how difficult it is, you can do this very easily. And Y is also equal to depth of AY over the determinant of A. So that's what we call a climate rule. Okay, lively. So that is that for the climate rule. So we have solved it. That's very simple. So that is that. Now let's look at it, maybe using examples for you to understand the concept well. We have the step, step one, find the depth of A. Two, find the determinant of AX. Find the determinant of AY. Okay, you have the steps, all of them there. They are there for you. Okay. Okay. So let's see this equation. Okay. Now we have solved the step of linear equation using Cramer's rule. We have 4, 3, 2, 1 multiplied by x is equal to negative 6, 8. So here we have the matrix already, and we have the x there, we have the b. So this s now can be xy. Is it okay? Yes, xy. This is our a. This is our b. So therefore we have ax multiplied by b. I think it's okay.
Yes.
Good. So let's say find the determinant of this matrix first. Let's find the determinant of that matrix. So we have this as, so this is our a here. And the depth of a is 4 times 1, which is 4. Minus 3 times 2, which is 6. So therefore we have depth of a as 4 minus 6, which is minus 2. Is it okay?
Yes, sir.
Good. Now let's find matrix AX. We do so by replacing the first column here by B. B is negative 6, 8. So replace 4, 2 by negative 6, 8. That's what you have here. Get the matrix AX. Then you find the depth of that one. So minus 6 times 1, you get minus 6. Minus 3 times 8, you get 24. Therefore, minus 6 minus 24 becomes what? Minus 30. That's the depth of AX. It's very simple. Are you okay?
Yes, sir.
Let's go to depth of find a matrix AY. What should you do there? How can you find matrix AY? We replace the second column here by what? By B minus 6, 8. That's what you have here. Of this AY, so 4 times 8 times 2, negative 12. Become 32 minus 12, which is 44. So here you are having 3 determinants. Therefore, x is equal to depth of x over depth of a. So minus 30 over minus 2, we get 15. Y is equal to depth of y over depth of a. That's 44 minus 2, you get minus 22. So these are the solution of x and y. Any question? Okay, let's see this. Solve the system of linear equation using climate rule. Here we have x. x1 minus 3x2 equal to 10. As equation 1. 3x1 as equation 2. So here let's form the matrix E. So the number here, equation of x1 is 1. So we have 1 minus 3, 3, 2 at our A. Can you see it? One here, is a 1 minus 3, 3, 2. Our x now becomes x1, x2. And B becomes 10, 12. Please, are you all following?
Yes, sir.
Good.
Yes,
So
sir.
let's find the depth of A. Depth of A. So 1 times 2 is what? 1 times 2 is what?
2.
1 times 2 is what? 1.
2.
2. Write 2 here. Minus 3 times 3.
Minus 9.
Become minus 9 become plus what? 9, which is 11. So that A is 11. It's very simple. Now let's form AX. So to me, I'm now in place of the first column here. I am replacing the first column by 10, 12. Are you okay? Are you okay?
Yes, sir.
Total of 1, 3 now become 10, 12. So I'm forming AS. Okay. So we get 10 minus 3, 12, 2. And I have found the depth of AS. So it becomes 10 times 2, 20, minus 3 times 12, 36, minus 36. So it becomes 20 plus 36. We get 56. That's the depth of AX. So how can we get the matrix of AY? Matrix of AY. How can we get matrix of AY? Are you here?
Yes, sir.
So how can we get the matrix of AY? Let's have that, please. But you are not following. You are not following.
I'm following.
How can we get the matrix of AY? You are following, but you cannot give me that one.
Sir, by
Sir,
placing
you
the
take-
first
Place the x2 over 10 over 12.
S2. Okay, so we just replace this negative 32 by 10, 12. Are you okay? Not over. It's 10, 12. And that one now will also give us 3, 1, 10, 3, 12. Are you okay? So you get found the depth of this. So multiply 1 by 12, you get 12 minus 10 times 3, you get 30. You have minus 12, no, 12 minus 30, you get minus 18. We are going to the 3 determinants. Therefore, x becomes the depth of x over depth of A. And y becomes depth of y over the depth of A. Is it okay?
Yes, sir.
So what is x? X will be equal to what? 56 over what? What depth of A? 11. And y becomes minus 18 over 11. Is it okay?
Okay, yes.
It's very
So
simple. That's all.
So please, let's go over it.
Over where? Where? Where do you have a problem? Where do you have problem?
So how it was solved? I didn't get it right.
How it was solved?
Yes, sir.
Let's get another example. Let's get another example. That's what we do. Than going over. So here, can you find the matrix A? It's already formed. Are you okay? So take the coefficient. So this is 4. This is the 4 we can see here. Pay attention, please. This is the 4. It's the coefficient of x. This one. Eh? Now the y now it become minus 8. So we have 4 minus 8 for the first equation. Is it okay?
Yes, sir.
The second equation we have C7. So that we can see C7. So that's my matrix A. Are you okay with that?
Yes, sir.
So that's the matrix A. Now what is x? X are the variable. That is x. Now B now will be the number C at the right hand side of the equation. So B minus 9. Are you clear now? You see, I have solved them for you, but because I want you to understand it, I am solving it with you here. So you have to pay attention. I'm not just reading the slides. I'm just solving it with you. Let's follow. Don't let me go far before you say that. Go over. When you have a feedback, let me. How did you get this on that? Then move on. Okay.
Yes, sir.
So now we have A, we have X, we have B. Let's first find the depth of A. What's the depth of A? Other than everybody should be able to do this one. What's the depth of A? Determinant of A.
4 times 7.
So tell me to write.
Is 76.
28.
28.
Wait, minute.
Minus
4 times 7 you what?
Minus 48.
minus 48. Minus 48,
Yes, sir.
So we can't put it. So what are you going to get there?
76.
76. That's depth of A. What the matrix AX? AX becomes what? What the matrix
Negative,
AX?
negative 8.
Negative what?
8 by
Negative what?
Negative 8
Left from the matrix. Left from the matrix of A.
minus 9.
What the matrix?
minus
And
8. Minus 8, 7.
how are you doing it? Matrix AX is what?
So it will be
What is
it
B?
will
So
be
you
negative
write the
8, 7.
so you
Why?
write the BD column.
So B.
BD is negative 8, 7.
Negative 8, 7.
So it will be negative 9, 13, and then the second column will be will be negative 8, 7.
Oh word, oh word.
Madam, thank you. If you are doing with the X, we will play the first column by this B here. And then you continue. What is the depth of AX?
7.
You are calculating.
Negative 63.
Negative 63. That's what?
Plus 104.
104.
What you want?
41.
21.
Huh? So do you have calculated?
It's 41.
If you continue to do this, I'll stop this for you. So what the mapping of E? There's what the A1.
4, 6 for the first column, and then the
4,
second will be negative 9, 13.
Good. Negative 9, 30. You have understood the concept well. Get replacement. So let's find the depth of A1. The one who says you have the problem. Are you following now?
Yes, sir.
So depth of A1. Yeah, what are you getting?
52
52
plus
Plus 54.
54.
And what are you getting?
106.
100 and what?
6.
Okay. So this was 106. Okay. So now what is X? What is X?
41.
Depth of A
X
over depth
is
of A. What is depth of AS? 41
over 76.
over 76. Good. What is Y?
106. 106 over
6 over
70.
70.
76.
106 over 76. I think you can simplify that one.
Yes, sir.
Simplify and let's go. Like a calculator, so just put it to give the correct one. Yes, I think the question is okay now. Yeah, Jonathan.
Sir, so in the case where the AX is equal to the 9, 13, and minus 8, 7, in the next one, can we, like before that one, can we put the, like when we put the distance, we do it minus 8, 7, minus 9, 13. Can we start, like, can we change it like that? Then when we read the other part, we just change it, or it should always follow this same.
No, when you change it to me, you are getting the Y.
Oh, okay.
First column is for X, second column is for Y. So if you want to start with the Y, then you just replace the second column by B. Or you can do that Y first.
Okay, sir. Okay.
And then you do the X. But if you are changing it, you want to do that one first and say X. You are wrong. You interchange the values of X and Y.
Okay.
Are you okay now?
Yes, sir.
Okay. Any other question, please? Are you understood it? You may not see the sense of it if we have way two simultaneous equations. But if you have 3, 4, 5, then you see that this is very nice one. This is very nice one. Okay. So when you simplify that, you are going to get 53 over 38. Eh? And L is 41 over 76. We got 3 by 3 here. Okay. Let me go on. I don't know whether I can teach you this one. Or I think you have issued the 2 by 2. Is that not true? Is that not true? Or you're okay with the 2 by 2?
We are okay with the 2 by 2.
Are you okay?
Yes, sir.
All of you.
Yes, sir.
Does it teach you how to talk? Yes or no? You're not talking. It means you are afraid of 3 by 3. You have 3 equations, you are solving it simultaneously. But this can make you. Okay, if you are not talking, then let me go. You see that if you have, okay, let me believe you on. If you are agreeing, then we get go straight. It's very simple. It's very, very simple. But the determinant of 3 by 3 is not the same as 2 by 2. Okay, you have to find that one. Now, what we are now going to do here is that if you're having 3 by 3 matrix, that because it is 3 equations, then you are going to get 3 by 3 matrix, which is a square matrix. Something like this. So you have equation 1, equation 2, equation 1, 2, 3. Very funny, eh? 1, 2, 3. We are taking the coefficient to form the matrix. 2 minus 3, 2, 1 minus 3. Get the first rule here. Can you do that?
Yes, sir.
Good. Then you have 1, 3, 2. Get the second rule. Then you have 3, 2, negative 4. Get the third rule. And your x becomes x, y, z. That's the variables. And b becomes 8, 5, 6. Are you okay with that?
Yes, sir.
All of you, are you okay?
Okay, sir.
But this is what we did to 2 by 2. Form A. You are picking the coefficient to form a matrix.
Okay, sir.
Should be a man and woman, eh? Should be both. Should be both. Don't let it teach you what you already learned at the SHS. You should go beyond that. And this way, in the SHS, you solve 3 equations. So if you call math, like we ask, let's we have a Venn diagram. You can have a 3 equation that we have to solve it simultaneously. And be there. You mark the 3 equations is simple. So let's keep it. Let's move on. What should talk?
Move on, sir.
Ellen, should I move on?
Yes, sir. Move on.
Ask me, Ellen. Ellen, are you there?
Yes, sir. Please move on.
Okay. That's good. So now with this, let's see how we can get the terminal of 3 by 3. And because we know how to find the 2 by 2, we are going on the same line. So we are reducing all this matrix 2 by 2 so that we can apply the 2 by 2 determinant. And this is how we do it. Please. We are now using, you can use any rule, but let's, for the sake of it, let's use the first rule. We have the first rule here. Now the sign for the first column is plus. Second one is minus. Third one is plus. So we are just alternating. Are you okay? Positive, negative, positive. Are you there? For the first rule. Are you okay with that?
Yes, sir.
Oh, good.
Understood,
You
sir.
have to respond so I can move fast, eh?
Positive.
So positive, negative for the first column here, positive, negative, positive. That's how it is for the first loop. Now I'll take the first entry here. That is 2 here. It's positive. So I get my positive 2. But I've got a positive, I won't write it because the first one. Are you okay? That's my 2 here. Then I am forming the matrix of all other entries which are not in line with this rule. So 3 is in line with this and this rule. Are you okay? So whatever left now will be the matrix. So we have 3, 2, 2, neg 1. This one. Can you see that?
Yes, sir.
Very simple. That's a 2 by 2 matrix now. If you have eyes, you can see it well, eh? Then I'll take the second one on the first row, which is minus 1. So that's what is minus 1 here. For the same thing, I'm now going to also delete or remove all things in line with minus 1. We'll be left with 1, 2, 3, minus 1. Are you okay? That was the here. Are you with me?
Yes, sir. Yes, sir.
It's very interesting. Eh? Very, very interesting. So we are left with the last one, which is what? This one.
Negative 3.
But don't forget, it is plus, minus, plus. Are you okay? But here, because it's a minus and there's a plus, it becomes minus 3. So we are now forming the matrix with the rest of those who are not in line. So minus now will be in line with this, and also in line with this. Are you okay?
Yes, sir.
So therefore, we are left with 1, 3, 3, 2 are this. So you can see that we can get the matrix determinant easily. Here 2 times this minus this. Are you okay?
Yeah.
This minus this. This minus this. Are we okay with that? So when we simplify, it will give you 2 times minus 7, minus 7, minus 7, minus 3 times minus 6 to give you 14. So the depth of A is 14. Shall I move on?
Yes, sir.
Okay. If there is, don't let me go, I can't go over. If you are using your tell me. You no problem. So we are not going to form AX. AX. Now AX now will be, we are replacing the first column by B. So we are replacing 2, 1, 3 by 8, 5, 6 to get our AX. Then find the depth of that. I think we are done here. It's okay.
Yes, sir.
So our AX now becomes 8, 1, neg 3, 5, 3, 2, 6, 2, neg 1. Do you agree?
Yes, sir.
Okay. So that is our AX. So that's where the replacement where I've done painting red with the red ink. So there's the replacement. Then here too we have taken the first row. We have plus, minus, plus. So plus here, minus, plus. Okay. So taking plus 8, That's what you see here. You'll be left with 3, 2, 1, neg 1. Is that not true? This one.
Yes, sir.
So that's the matrix that we are forming. Now minus 1. So minus 1 also flow. Yeah. The minus 1 also now will be in line with what? What we left there? Those who are not in line with minus 1. With what? 5. Hey, you cannot see you. This is the 1.
5, 6, and 2
Hey,
negative
not 5,
1.
6. Not 5, 6. Not 5, 6. This 1 here.
Okay. So 5, 6.
Hey, are you going downward, eh? Okay, 5, 6, eh?
And 2
Come on.
2
negative 1.
negative 1.
We are going column by column. Okay, no problem. 2 neg 1. That's what you have here. Now plus minus 3. So this is minus 3 here. So we also let report. Hurry up, hurry up.
5, 6,
Plus minus
3, 2.
5, 6, 3, 2. You get this one. Then you know how to find the determinant of 2 by 2. So 8 times 3 minus 1 minus 2 times 2. You get minus 7. Minus, if I go here, 5 times minus 1 minus 5 minus 2 times 6, we get 12. That will give minus 17. Okay, we have minus 3 here. When we go here, 2 times 5 is 10. Minus 6 times 3 is 18. So 10 minus 18, you get minus 8. And when you simplify all this, it will give you minus 15. Are you okay with that?
Yes, sir.
So that's the depth of AX. Then we do so for Y. Y now will be the middle one. Y will be the middle one. So let's go and find the Y, the matrix of Y. It means we are replacing the middle one by 8, 5, 8, 6. Are you okay?
Yes, sir.
One maintain other columns. So there we have the same thing. We are plus, minus, plus. We are plus 2. We are left with 5, 2, 6, neg 1. You form this one. Now minus 8. You get 1, 2, 3, neg 1. You get it. Are you okay? Now plus minus 3. You get 1, 5, 3, 6. Are you okay with that?
Yes, sir.
Then find the depth of each matrix. That will give us all this. And when we simplify, give us 49. We have the last one. That is Z. Z. Z is for the last column. The last column. So we will replace the last column by 8, 5, 6. Get it. So now I am allowed you to find the depth of AZ. Find the depth of AZ for me. Everybody. Find the determinant of AZ.
Morning. How be case ana? Na weekend they come. And a new case. And a Monday.
You see, because you don't meet your microphone, we heard everything.
Sir,
Yeah.
determinant of Z, AZ is 31.
31. Any different answer? Don't forget it's plus, minus, plus. Are you okay? For the first rule. You can go on. This is why we can minus, plus, minus. Then plus, minus, plus, and so on. But we are taking only the first rule. Any different answer, please? So if so, what is x? What is x? X will be what? X will be equal to what? Det of x over det of a. What is det of x? Minus 15. We have that of a as what? That of a. What did you get? Unless we go back. Okay. Let me go forward so that I move on. Yeah, that AZ is negative 31. Okay. That of A, we got 14. So S is equal to minus 15 over 14. Y is equal to 7 over 2. Z is equal to negative 31 over 14. That's all. So we're able to solve 3 systems of equations simultaneously. Is it difficult? Is it difficult to understand? You're not talking. Is it difficult, please?
No, it's not difficult, but confused.
No, sir.
Good. So you cannot solve 3 equations simultaneously. That's good, by the climate rule. So you can try all this. These are the 2 by 2. All of them are 2 by 2. You can try all this. And when it can be 3 by 3. So if not difficult, you can just try your hand on them. Are you okay?
Okay, sir.
All of them, 3 equations. Okay. Let's meet our microphone, please. Then let's see all what we have done. Let's move on to word problems. Word problems. And that will be the end of the linear equation. We have done a lot here. I've done a lot here. Now, the problem will be put in the word form. And you have to formulate the linear equation out of them, and then you solve them. So if you are having such problem, the word problem, I know it's difficult for some of you. You don't like it at all. And this one now may depend upon your understanding of the problem at stake, or maybe you are weak in maybe mathematics. But now let's see how you can. I don't know the steps that you can follow. So let's see the steps in solving word problems. First, read the problem carefully for better understanding. Are you okay? Read the problem carefully for better understanding. So read, if not once, read and read and read to get the meaning. They read the meaning of that. Now, as you are reading, if you see any unknown quantity, represent that quantity by a variable. Or there are more than one variable, represented by variables. So represent the unknown quantities by variables. 3, break the problem into small pieces. Break the problem into small pieces. As you're reading in what line, you break the problem into small pieces. Don't just jump them. Then represent each piece by an algebraic expression. Arrange the algebraic expression into equations. Now solve the equations check your solutions in the word statement. So these are some of the steps that you can follow when you are solving word problems. So let's see how you can apply these steps in the following problem. Can I move ahead?
Yes, sir.
Yes, sir.
So let's do example 1. If 4 times a certain number is equal to twice the sum of 5 and that number, find the number. If 4 times a certain number. Now this a certain number, you don't know it. Okay, so represent that one by a variable. So you can say that let S be the unknown certain number. Are you getting my point?
Yes, sir.
Good. Take your time and do it one by one. So 4 times a certain number is equal to twice the sum. Is equal to twice the sum of 5. So twice the sum of 5 and that number. What the sum of 5 and that number? The sum of 5 and that number is the same as what? 5 plus that number. That number now is x. Are you okay?
Yes.
Let me go over it again. Take your time. Somebody is writing on my screen. Hey. don't put anything on your screen other than it to come to me. And you'll be hot. Your name appears when you do that. Let's move on. So 4 times a certain number, I said, represent unknown quantities by variable. So a certain number is unknown. So let that one be x. We are there 4 times x. Are you okay? You get that one as one piece. It's equal to means equal sign. So bring equal sign. So but forget about that one thing. Equal to twice. You mean the twice. Twice means what? 2 times. Are you okay?
Yes, sir.
2 times, not twice. So but forget about that twice. The addition. The sum of 5 and that number. So and number is the same as x plus 5 or 5 plus x. Is that not true?
Yes, sir.
So that's what you have here. The sum of 5 and unknown number is 5 plus x. Then we are going to twice. So twice that will become 2 times 5 plus x. Is that not true?
Yes, it is.
Yes, sir.
So now let's join all this into one equation. So we say that go over the statement again. 4 times we have 4x times a certain number, that is 4x equals, we bring the equal sign. Eh? Twice we bring the 2. Then the sum of 5 and that number, 5 plus x. So we get a linear equation like this. You see how simple it is?
Yes, sir.
So nowadays we can solve it easily. We have a bracket, we get expand the bracket as we did when we met face to face. So when we expand, get 4x equal 10 plus 2x. So making x the subject, we get x equal to 5. Then we check if it is true. So let's go back to our formulation. Whatever it is, put the 5 there and see. So here you have 4 times 5. It's what?
20.
4 times 5 is 20. Good. When can you hear it's also 5? So 5 plus 5?
10.
10 times 2.
20.
Therefore, x is 5. Is it okay?
Yes, sir.
At times you may get the answer that will not satisfy the equation. So having gotten your answer, go and test for it to see if it's real answer. Okay. That's good. Let's see another example. So let's go to example 2. The sum of three consecutive integers is 303. Find the numbers. The sum of three consecutive integers is 303. Find the numbers. I'm sure after that we know integers.
Yes, sir. Yes, sir.
So if we are saying consecutive integers, we mean that the number that follows next to the other. So assuming if the number, the first one is 5, the next one becomes 6 and 7. We are doing 3 of them. So if it is 5, 5, 6, 7 are consecutive integers. Are you okay?
Yes, sir.
So let's represent the first number. It is unknown. The sum of 5 integers. We don't know that integers. And we are saying if we don't know anything, let it be what? A variable. So let's assume that that first number there is x. Now, if I am on an integer, to get the next integer, what should I do? Let's say I am on the number line, I am on number 5. How can I get the next number?
You add 1 to it.
Add 1. So therefore, the next number now becomes x plus 1. We have x at the first one, x plus 1 at the next one. Now x plus 1 plus 1 becomes x plus 2. So these are 3 consecutive integers. Please, are you okay with that?
Yes, sir.
Good. If so, now the question is that the sum. The sum is we add all of them. And when we do so, we are going to get 303. So let's add all of them and equal 303. So simple. So we have x plus x. This x is the first one, plus x plus 1. So this is x plus 1 plus x plus 2. So we have 3x. So x plus x plus x becomes 3x. Now 1 plus 2 becomes 3. Therefore, we have 3x plus 3 equal to 303, which is a linear equation. Therefore, you can solve for x. So when 3 goes here, it becomes what? 303 minus 3. What is what? What is what? 300. 300. That's what it says, 300 here. Then I will divide here by 3, here by 3. I'll get s is equal to 100. S is equal to 100. So it means if my s is equal to 100, the next number becomes what? 100 plus 1 is 101. Are you okay?
Yes, sir.
Next one becomes 100 plus 2 is 102. Therefore, 100 plus 101 plus 102 is the same as 303. So your answer is correct. I hope you are not confused.
Not at all, sir.
Okay, let's go ahead. Maybe I'll see what I want to ask. Let's go ahead. Let's solve another one. Good. Good. Let's see the third example. I want Ellen, read that example play for me. Ellen. Is Ellen around? Ellen.
Sir,
Hey, read it for us. Example 3.
example 3.
Yeah.
The average of 4 consecutive even numbers is 87.
Okay.
Find the difference between the smallest number and the largest number.
Good. I'm sure you know average. If I find average, you know how to do it. Average, you know how to do it. What's one average? We add or we divide by total number. Are you okay?
Yes, sir.
That's average. So that's why it's there. Now let's see what will be a pro. So you don't know that number. You don't know the even number. You know even numbers, eh?
Yes, sir.
So on the number line, how can you get consecutive even numbers? Maybe you're on the even number to get the next even number. What should you do?
You add 2.
In the same way, if you're on the odd number, you want to get the next odd number, you add 2. You move 2 steps. So assuming our even number is 6, 6 plus 2, 8. We are the next even number. Did I get the point?
Yes, sir.
Good. Time is almost up. So let's be I add 2 to this and get the next number. So S plus 2. Third number is let me add 2 to this number 2 plus to get S plus 4. Fourth number, let me add 2 to become S plus 6. Are you okay?
Yes, sir.
So these are the 4 numbers, 4 even numbers. And the question is saying that if I found the average, it means if I add all of them, divide by 4 because they are 4, it should give me 87. So let me add all and divide by 4. So when you add all, you are going to get 4x plus 12. Are you okay? Then divide by all. When you add all, you divide by 4, you get 4x plus 12. Let's see, we have 1, 2, 3, you get 4x. And this one is plus 12. Then that one will be over what? 4. But over 4, we can cross multiply. When you cross multiply this one, you multiply here by 4, you get 346. You know every number is over 1. So you multiply 4x plus 12 by 1 and multiply 4 by 87. Are you okay with that?
Yes.
Or even here. 4 can go into 4, can go to 12 here. Are you okay?
Yes, sir.
Then you have 4x.
3.
Plus 12. Now all about, not all over 4. That's the average. That's the average. So we are this was equal to 87. So 4 can go here. 4 can go here. Or can be factorize 4 out of this numerator. And 4 can divide it. So when 4 goes here, you get x here. And when 4 goes, you get 3. Is that not true?
Yes.
So you will become x plus 3. Instead of being cross multiply, 4 can go into it. You can go do it this way. This is why I call it 81. 87 rather. So you can make x the subject by taking the 3 to this side. So you get x equal to 87 minus 3 will be 84. Which is even number. Can you see that?
Yes, sir.
Here I cross multiply. So I multiply here by 4. So I got 348. It's also correct. Therefore, when you send the 12 to others, you get 336. Divided by 4, get 84. Therefore, the first number is 84. 84 plus 2, 86. 82 plus 4, we get 88. Are you okay? Now 88 plus 2, you get 90. So these are the 4 numbers that we are talking about. And the question is saying that the difference between the smallest, what the smallest is?
84.
And the largest, what the largest is?
90.
So the same as 90 minus 84, you get what? 6. You have to find the difference between the highest and the least. After getting your numbers, you can go straight. Or even this one from here, we know that the least now is what? X. That not true? This is the least. And the highest is what? X plus 6. So you can subtract X from X plus 6. You get the same 6. Is that point okay? This was the question also if you find all the numbers, if you find the difference between the highest and the least. So we need not even to find the number before you subtract. You can go straight. But subtract the first number with x from x plus 6. You see, get the 6. The time is up, so just a minute, we can't do anything otherwise. Any question? So that's all for the linear equation. We have done a lot into it. So the word program, they follow on and on and on. I've solved some for you. I've given some for you to try, and we have edited. Now, when you go there, you have edited one day. Go and do it and submit it. Then later, I'll also upload this one also there for you to go and do it and submit. Is that okay?
Yes, sir.
Good. So first submit the assignment to 1. When the deadline elapses, then I'll also upload this one thing. And then you submit it. If you look at this one, they are very simple. The sum of 4 consecutive multiples of 3 is this. Find the numbers. The average of 5 consecutive odd numbers is this. Find the quotient of the large. Quotient means you are dividing. John and Ernest are very close friends. Their ages are such that Ernest is 5 years younger than John. In 10 years ago, John was twice as old as Ernest. How old are they? They are all that. So we can just try all of it. No, not try all of it. I'm going to solve this when the time comes. So I'm done with the linear equation. So we are done. We are not even done with the unit 2. We are left with inequality. When are you meeting me online? Next, the weekdays. When?
Let's do it on a Wednesday or
Discuss it. Discuss and let me know. Is it okay?
Okay, sir.
In the evening. Discuss and let me know. Because I wanted to go to unit 3 our next a week today. Go away. By the time it's running. Or I can we can meet next week to do this one, the inequalities. Yeah, that was very important.
Next week is break. Easter break.
30 days, although it's a break.
Yes, please. Next week.
By you the weekend, are you enjoy the break there? The daytime people. We are meeting on Saturday. Go away. Let's meet. Are you okay?
Yes, sir.
Let's meet. Okay, we have some who go for conference.
Yeah,
Is anybody here who go for conference?
Yes, sir.
Then we are going to enjoy next week. Okay.
Then you discuss the day, then
we don't have any issue to go do anything because the conference is there.
Yes, sir.
So we don't have any problem there. Then we are enjoying ourselves next week, Saturday. But the advice is that as we are enjoying holiday, are you okay?
Yeah.
Let's go to the inequalities and the unit 3. Unit 3. Okay, it's about polynomials. You know polynomials. So unit 3, it's function. Polynomial is part of the rational function and co. Try to see if you understand everything there. So that if God permits, the next meeting, they move on to find the calculus straight. Are you not reading the book?
there's no this thing on the elements.
There's no book there.
Hey, I uploaded the book there. Go to my element.
Yes, sir.
No, only the this thing, the model 2.
That's the model. I'm talking about the model. That model is your book. book that I wrote with Dr. Stephen Okla. Are you okay?
Yes, sir.
It's the one that we are using, the book that we are using for your course. So let that one be, apart from the Bible, that one will be the second one. Or the Quran, those Muslims. So go through the book. So go to the third unit right there, about the functions. Now for inequalities, you can go through them. There's a part of the unit 2. Go to the inequalities. Then if everything is okay, if there's something wrong, or you don't understand anything there, then you call me to meet online. Are you okay? Are you okay with that?
Yes, sir.
Yes, sir.
I don't disturb you with the meeting. So go to the inequalities. If
So
some
you
of you
can
are very
disturb us.
what? Without.
You can disturb us.
Maybe at the time you are not coming, you have become wallet. Like the first one that we scheduled. Only few kids. I don't want that one. So you just go through the inequalities. The last part of unit 1, unit 2. From the book. Then see if everything is okay. And then from I'll send the inequality site also to you. I'll upload it over there. And that's all the detail of what is in the book. Are you okay? You see, the slides are detailed than what you have in the book. Is that not true? And not okay?
Yes. Okay, sir.
So I will upload the slides of inequalities also there for you. I'm just making some preparation there, adding something there. I'll put that one also there for you. So you go through it to see if everything's okay. Then you try to go to a function unit 3. I wish if we can start calculus next meeting. Calculus next meeting. That's the part that I wrote. All what you have done were written by Dr. Okra. I started my unit from unit 4. I had to do something there. Calculus is very interesting. Thank you very much. The time is up. So go and rest or continue. If you don't have any question for me, goodbye.
Okay, goodbye. Thank you, sir.
You're welcome.